All right. Whilst I'm talking, you may want to open those software and then the Excel sheet so that when we start the practical, you will follow along with me. So let's start with correlation and regression. Who can give me another word for correlation? Who can give me another word for correlation? Annie.
Connection.
Connection. Jemima.
Relationship.
Relationship. Joel.
Association.
Association. I love that. Anybody else? Irene.
Nexus.
Nexus.
Nexus. Yeah.
Okay.
Nexus.
George 30.
Link.
Link. I love that. I love that. That's good. So all of these shows that correlation has to do with the connection between two or more variables. Now you want to know that correlation can be strong and correlation can also be weak. For example, the relationship between a brother and a sister is stronger, and the relationship between two cousins are weaker, generally speaking. So correlation can be strong or weak, but it can also be positive or negative. What do you think is the correlation between consumption and income? Is it positive or negative? Consumption and income. Christian Morty.
It is positive because as income rises, consumption follows suit.
Perfect. What is price and quantity demanded relationship? Po or net? Aaron. Kwame.
It's negative.
Why?
Because as price rises, quantity demanded reduces when we are dealing with rational individuals.
Very good, generally speaking. Now, this positive or negative, it doesn't mean anything good or bad. It's not a good or bad thing. So you don't attach morality to it. Now, that means that you can have a very strong positive correlation. And it also means that you can also have a weak positive correlation. And you can have a strong negative correlation and a weak negative correlation. Joe Adonko, I hope you are with us. Okay? I hope you are really with us. So let's look at how to measure correlation deeply. The relationship you see on your screen, is it positive or negative? Jemima?
Positive.
Positive. What about this relationship? Is it positive or negative? This second relationship, is it po or net? Felicia?
It's negative.
Negative. Why?
Because they are moving in opposite directions.
Very good. So correlation is a very powerful thing, and it can always be positive or negative. And once again, remember that the fact that it's negative does not make it bad, and it's positive doesn't make it good. Okay. Now, let me ask you, based on what I've just said, let me ask you, which of these two has a strong correlation? What I'm about to write, which of them has got a strong correlation? Negative 0.92 and then 0.9. Which one has a strong correlation? Which one has a strong correlation? These two things that I've written. Gift Nyako.
Negative 0.92.
Why?
Because we deal with the absolute figure.
Very good. So
So
correlation is a very, very powerful thing. The statistic you use to measure correlation is called Pearson. And that is when you assume that the data is normal. And the statistic you use to measure correlation when the data is slightly skewed is called Spearman. Okay. And what we're about to do, we shall be doing the Pearson's correlation, because that one Most of the data is numerical data, not categorical data. Okay, so let's take a couple of examples. Okay, first of correlation, graphical examples before we go into the nitty-gritties. I have some drawings on your screen right now. What I want you to do is to tell me whether the relationship, what kind of relationship is being shown here. So let's look at the first relationship, okay, this one here. What is the relationship being depicted on your first screen? What is the relationship? Alice.
Positive.
Sorry, I can't hear you.
Positive.
Positive. Why?
Because it's moving in the right direction.
It's moving in the
Right direction upwards.
right direction upwards.
Yes, please.
Okay. Right direction upwards. Okay. So it means that the y, as the y is increasing, the x is also increasing. Or as the x is increasing, the y is increasing. Very good. Okay. Let's go to the next. What's the name? What was the name of the person? Let me just make sure. All right. Please use your full names. Okay. Use your full names or use your ID. Either one is fine. Your full names or ID. Let's go to the next one here. Okay. The one on the bottom left. What relationship is being shown there? Stephen is shown.
Thank you, Doc. As a negative relationship.
Good. Don't explain. I get it. Now let's go to the one on the top right. Okay, the top right here. What relationship is being shown there? That one is tricky. It's not straightforward. What relationship is that, Christian Martin?
We can say that's a quadratic relationship.
It is a quadratic relationship. And finally, the one on the bottom right. What relationship is being exhibited there? What relationship is being exhibited? Alice Kuniba.
Doc, logistic relationship, but the explanation you gave, I don't understand it. So if you could explain it clearer to me, so I understand why it's a logistic relationship.
Where did I give the explanation?
The link you shared that we should watch the video.
Okay. Very good. So I've shared a link, and that link was helping you to be able to establish the relationship in that regard. So if you are able to get to the relationship, that helps you significantly. All right. So a limited dependent variable regression. Note that down. A limited dependent variable regression. A limited dependent variable regression. There are some kind of regression where the dependent variable is 0 or 1. And those ones are the ones that exhibit the situation that we are looking at. Logistic, probit, tobit, censored, truncated regression. All of these show that. Now, with such kind of thing, when X is rising, Y rises and rises very fast and never stops. When X is falling, Y falls very fast, asymptotically. Okay, and that is why these are logistic or probit or tobit regression. When we get to the end of the lecture, I will explain it all to you. Okay. Now, the next thing I want us to look at is the examples here. I want you to tell me the relationship on your screen I'm about to ask you. Tell me whether the relationship is positive or is negative. Whether the relationship is positive or negative. So let's start with cold weather and air conditioning cost. Please think, because once you say it's positive or it's negative, the other person cannot say it again. Because once you say and you are wrong, I just have to give the answer. So you have to think deeply before you say the correct answer. Okay, so cold weather and air conditioning costs. Not air conditioner, but a cost. Who can give me that first one? What is the relationship there? Frida. Frida.
It's negative, sir.
Spencer, can you mute yourself, please? Spencer, mute yourself until you are called. Okay. All right, so that is negative. Education and salary. Susan Aiden.
Sir, please, negative.
Education and salary is not negative. It's positive. When you educate yourself, your salary is also going to go up. So they all move higher. If you get more education, you're more likely to get more salary. Okay, generally speaking. Okay. I want you to think through these things, okay, before you are able to give me some answers. Smoking and longevity. Smoking and longevity. Michael Edu.
Sir, it's negative.
It's negative. That is
Yes,
true.
sir.
When you smoke more, your life is likely to go down. So your longevity will go down. That's a negative link. Depression and suicide. Depression and suicide. Richard Labby.
It's positive.
It's positive.
The likely,
That's true.
the more depression you have,
It's
the
positive.
likely, like the higher likely, yeah.
GPA and SAT score. GPA and SAT score. Eugenia Agbati.
Please, it's positive, sir.
It is positive. Work and leisure. Work and leisure. Yvonne Yenge.
Sir, please, it's negative.
Why?
The more work you get, the less leisure you have.
That is true. Very good. So you should know generally some established relationships. Okay, these are general ones. These are really general established relationships. So with that in mind, let's look at our data sets that you have in Excel. By now, please open your Excel. And the data set is about a student who is writing his long essay. The student's long essay is entitled Determinants of Demand in the Alcoholic Beverage Industry in Ghana. That's the title of the thesis. Okay. Now, this person has observed that there are previous studies on the subject. However, they did not consider the effect of location and occupation. So there are studies that are there that shows that price is a determinant of demand for alcohol. Complement price is a determinant of demand. Income is a determinant of demand. But they've not looked at location and occupation. So this person was able to justify that they've not looked at location and occupation. The person was also able to indicate that few studies have looked at religion. All right, they've looked at religion. However, they have not considered Buddhism or Buddhist in their religions. They only consider Christian and Muslim, and they've not considered Buddhist. Okay. And so this person has identified these gaps. Anytime you are writing your long essay, and you will write your long essay, which is 6 credit hours. And your long essay, by the way, is indicative of the fact that you are writing a book. So you are writing a book, all of you here, you write a book which is made up of 10 to 20,000 words. That would mean that you need to bring in some gaps, some problem statements. And the gaps are theoretical gaps. You're able to find some of these things with your supervisors. Conceptual gap, methodological gap, empirical gap. A typical example of an empirical gap is something that has been applied in other parts of the world, but have not been applied in your country or in your continent. And there are some peculiar characteristics of your continent that makes the application of that thing even more powerful. And yet it's not been applied, say, in the African continent. That is an empirical gap. A methodological gap may be a theory or an analysis that have been done, like people have been using ANOVA to do some work, but you have observed that instead of using the ANOVA, you want them to use regression. That is a methodological gap. So you will identify some of these gaps and you will write them down as your problem statement. If you want to write a very good thesis, long essay, dissertation, journal article, read on the MIT website, which I've given you here, okay, how to write a research journal article in a scientific journal. That's some wonderful information for you on how to do some very good work. So let's go back to this student who is writing on the data. So the person is looking at the determinants of demand in the alcoholic beverage industry. And now what we need to do is to establish a QSFACO. Are you with us? A QSFACO. Okay. You collect data on Brukutu Ventures. Yes, Yvonne, you have a question. You collect data on Brukutu Ventures, and then after collecting the data, we're able to see that, please take note of these things, very important, that management have concerned and want to determine which other factors, and these factors are called predictors, which other factors aside price can affect the quantity demanded of gin bitters. They were able to identify that the factors include, this is the quantity demanded of gin bitters. Apart from this price, which is a numerical variable that affects the quantity demanded, complement price also affects the quantity demanded. The income of the people, take note of the words, not the shop, but the income of the people also affects the quantity demanded. The location of the shop, that is the shop that sells the gin bitters, the location, whether it's in an urban or rural area, can affect the demand. The occupation of the people can also affect demand. The religion of the people can affect demand. Let me ask you a question. If you look at these variables, which ones are categorical and which ones are numerical? You can tell me. Which ones are categorical and which ones are numerical? The C is the complement price of gin. C is a complement price of gin. For example, a complement of gin is kebab, lime. All of these are complementary. So they are prices. That's what you see here. All right, so who can tell me which variables here are numerical and which are categorical? Lucian.
Okay, so for numerical, there's the quantity, price, complement, and income. And for categorical, is the location, occupation, and religion.
Thank you. So what do you see as the unique feature of the categorical variables from the numerical variables? By the way, this topic is compulsory, Preston. And it is also, there's an assignment to it that I'm going to be giving you, but it's also going to be the compulsory question for your exams. So it's nice you are following like all of you are doing. What is a peculiar feature of the categorical variables? One thing about them is that they are English letters. They are not numbers. They are written in English. Now let's look at the categorical variable called location. Another name for it is called a dummy variable. All those that have English letters are dummy variable. The location has how many levels? Who can tell us? Location. It has how many levels? How many levels of location are there? Christian.
Yes, I can count urban, rural. Yes, so 2.
How many levels of occupation are there? Frida.
Sir, it's 3.
It's 3. How many levels of religion are there? Abigail.
Sir, it's 3.
Good. So we have these 3 levels of the information here. Okay, I'll ask you some questions about them pretty soon. And I know that you also have your data loaded, opened. Now I sent you an email and I told you that you should generate the descriptive statistics in Excel and also generate the correlation in Excel and also generate the regression in Excel. Can you tell me if you did it? Raise your hand, please. Those of you were able to generate all these things in Excel, and you have them now. Okay. Raise your hand and let me see. You generated them and you have them now. You have them now to the extent that if I were to ask you to show me, you can take some time and show me. Let me see by hands, those who have them now. Let me ask you, Richard Loudy. Richard. Richard.
Yes, sir. Yes, sir.
Do you have all of them in Excel?
Yes, I do.
All three or two?
Okay, what I have is the correlation and then the descriptive statistics.
Okay, so there are three of them. Do you have all three or two?
Two.
Okay, keep your hand up. Harriet, do you have all three or two? Harriet Abbey.
All three.
All three. Okay. Why are some of you all of a sudden joining? Those of you just joined, I want to ask you why you just joined. Those of you just joined, you know yourself, I don't want to mention your name. I want you to rather unmute yourself and tell me why all of a sudden you raise your hand.
Because I have only two, I don't have the three.
That is why you now joined.
Because when you said all three, I put my hand down, but I realized that one had all two, but the hands were up. So I decided to join and let you know I have two.
All right, I get it. Now, who was the other person who joined? I know the person though. The person who joined.
I also have two. I don't have all the three.
So you lowered your hand because of that. Then you brought
because you said.
All right. Okay.
Yes.
So now there are 9 of you. Keep your hand up. Whether you have 3 or 2, keep it up. All right. Okay. So those of you, I think I don't have to ask everybody. Those of you who have all 3, unmute yourself. You don't talk, I'll see it. Those of you who have all 3, unmute yourself. Miriam, are you there? Let me see. Okay. All of you have all 3. Please unmute yourself. Let me do something. And then those of you who have 2, keep your hand up. Don't unmute yourself, but keep your hand up. Ladies and gentlemen, what I'm about to do is very important. Very important. Okay. I'm taking note of something very important because this is your first assignment. In case you didn't know. Some of you didn't know that it was an assignment. And so, go and work along with me. And then open your R Studio and work along with me. I'm going to show you my R Studio. So please get your R Studio open. When you open your R Studio and you also open your Excel, this is what I want you to do. Please go along with me. Or do I have to give you some time to open your computer? Is that it? You sorted? Good. So I want you to go to your Excel and go and copy your Burukutu Excel data, the one that has the location, occupation, and religion, the one with some English letters. I want you to please go to that and copy the data set. Then go to your R Studio. You have already typed this command, which is the gen read.delim clipboard. You have already typed that command. Click in that command. Click on anywhere on that command and let the cursor be blinking. I'm doing the same. Okay. So I'm going to my R. You see the command. I have highlighted the command in my R. Click it. And then if you have already copied the data, in Excel and you are now in R, run it. Once you have clicked on the gene, run it at the top, you see run and click run. When you click run, the data name will be showing down there in the blue. It will show down there in the blue. Mine is not shown, don't look at mine. But in order to be sure that the data is loaded into R, just highlight the gene, G-I-N alone, and run it. And you will see a beautiful data populating down there, like I have down here. Remember, if you are lost, let me know. Please raise your hand if you can see your data in the console, like mine is showing. Raise your hand if you can see your data in the console, like mine is going. There are over 70 people here, so, you know, I'm expecting most of you to be following me. If you are not following me, it's not a healthy thing at all, because I'm going to ask you the process in an exam. So it's nice you are following me. So do some, okay? Try and do some. Okay. Now, majority of you have loaded the data into Excel. So you can see it just as mine is shown. The next thing I want you now to do is you fix the data into the memory of R. And how do you do that? By running the command which is attach gene. I have highlighted mine. If you do not have yours, type mine in yours quickly, then run attach. So click attach, that will fix the data to the memory of R. Then go to your library mass package. The library mass package. Run the library mass package. When I say run, I mean click on it and click run. I'm assuming that you have already installed the package. So because you've installed the package, I can now say you should run. Please lower your hands. And then in case you have a question, let me know.
I have a question, sir.
Yeah.
Please, can you repeat what you said we should do with the attach again? Sorry.
With attach?
Yes, please.
Okay, all I'm saying is I just type the attach, which you have already typed. Once you've typed it, just run it.
Okay. Thank you.
Now, you should also run your library mass. Okay, run your library mass. Yes, Christian.
Hello, sir. I have a situation. The run command is not showing, although when I copy the data and click on gene, it blinks. But at the top left-hand corner, I can't see the run command.
Is that how it's always been?
Previously, I saw it, but I don't know why.
Okay. When you do Control Enter, once you've clicked on the gene and you've copied and everything, and you do Control Enter, does it show the result?
No, sir.
You mean you do it, you've tried it with Control Enter and doesn't show?
Yeah, just a moment. I'm copying the data again. Just a moment, sir. I'm copying the data. Control Enter. No, it's not responding.
Did you click on the name?
Yes, I click on gene. The gene equal to read dot
okay. And then you did Control Enter and nothing showed in the console.
No, sir.
Nothing at all showed.
No, please.
Okay. When you highlight only the gene, you highlight only the gene, G-I-N, and then do Control Enter and tell me.
I wrongly even just.
Hello, sir. So after running the attach, I have a statement that says the following objects are maxed from.
Yeah, don't worry. It's okay. Don't worry about it. Christian, how far?
Boss, please proceed. I think I'll recover.
Good. Or one thing you can do now quickly is just turn off your RStudio and reopen it. Okay. So,
all right, sir.
Guys, because we have some more to do, if you don't ask your questions now, as we go, the questions can pile up. So you ask as we go quickly. Yes, Kwame.
Yes, I was able to run it last week, but I'm having issues right now. When I copy it and I click in Gin and I have the cursor blinking, when I run it, I'm just getting the same Gin, like the code down there. I'm not getting the
but that is a code. That's all you
produced.
need. In order to see the data, you have to highlight the JIN, all of that alone, before you run that.
Okay. And am I to do that, please?
No, do that and then tell me. Do that and tell me.
Okay, all right, okay. It does come. Thank you.
Okay. Now, let's move on. You have run your library mass. You can do your table and then create your contingency table. We spoke about this contingency table the last time. So I'm not going to talk much about a contingency table, but this will guide you to know about a contingency table. So familiarize yourself with it. Now, I can ask you, and this is important because all the time I'm now going to see, there are 14 questions in your exam about all that we are doing that I will ask you, which is compulsory. There are 25 questions in your group assignment, which I will ask you, and those are the same thing I'm about to be doing. We run, we show, we discuss. We run, we show, we discuss. So I'm going to be running, show, discuss, running, show, discuss. So don't only listen, but also make some notes along the line. All right. Kwame, lower your hand, Sophia.
Yes, so I wanted to find out, do we run the detached too?
Don't run the detached.
Okay, thank you.
Now, let's go to the first thing you might be told to do is to determine whether a particular numerical variable is normally distributed. And that's something you want to put down for your personal note. Okay. How can you tell whether any of the numerical variables is normally distributed? How can you tell whether quantity demanded is normally distributed? How can you tell whether price is normally distributed? How can you tell whether complement price is normally distributed? How can you tell whether income, M, is normally distributed? And I'm talking about these variables here, the numerical variables. How can you tell whether each one of them is normal? Well, to determine the normality, you can use a histogram. And this is a histogram of quantity demanded. It is in different rainbow colors. If you have learned a bit about histogram, you would have known that this information we are having here shows that histogram, this quantity demanded is not normally distributed. Okay. How? How do we know that? Okay. We know that because for a variable to be normally distributed, the bars, the bins that you see here, the red one will be below the orange one. And then the bars will be climbing, get to the top, and then they'll start falling. That will give you the clue the variable is normally distributed. But what we have here, it doesn't show that the bars are climbing, they get to a maximum, and then they start falling. No, that's not what we see there. You see some of the bars are falling and rising. You know, it doesn't really show clear-cut normality. There's another graph which you can use to determine whether quantity, remember it's quantity that I did, and I did that with this command, rainbow command. You can also check whether a particular variable is normal. Okay. Let me just do something I've never done before. Let me just see if I can show whether quantity demanded is normal just by using box plots. Just want to check to see. Okay, so I've just did a box plot of the data, the quantity demanded. Okay, and the box plot that I did, the box plot is not a very good thing to use to show normality, but I've just decided to do that for you to just have a feel. of that. But there's a better plot that you can use to show whether quantity demanded is normally distributed. Remember, quantity demanded is a numerical variable, and the plot is known as density plot. That's a plot I've just highlighted, and you also have it in your slides. Run it. Plot density into bracket Jin $kill. Okay. And then we will include something at the bottom, which is known as rugged jitter. Okay. So you will see the plot here. I've run the plot, I've shown the plot. You can change whatever color you want to use for the plot. Okay. You can use whatever color that you want to use for your plot. So if you are able to do that plot, just raise your hand and let me see. If you're able to do the plot, just raise your hand, because I want to be sure that some of you are following me. So that is a plot I've done. I've just shown some bit of coloring.
Yeah.
Hello, Doc.
Yes.
Please, I have, but my curvatures do not look like yours. The first shape, the first bell doesn't look so prominent like yours.
When you say prominent,
like mine is more like looking at normal, but then you can see the first one, the first mode where it turns. Mine is very small. You can't even see it as so prominent like yours. You see, yours is very sharp. Mine is just something small.
And what command did you use?
No, the same. I use the plot density P, called the same thing you here. That is what we had in the
Prof, okay, so it's different.
Yeah, so it's plot density, then into bracket P.
Yeah,
then
yours
comma,
is P.
C-O.
My dear lady,
yes,
yours is
his
P.
wasn't.
Mine is kill. So you can change the letter P to kill.
Yeah.
Okay.
Thank you.
That's all. Just go and remove your letter. I told you that any one of the numerical variables, you can check the density. Okay. So just do that. Okay.
Looks
so this is the
Proof.
density you get for the quantity demanded. Okay. Please lower your hands. It's just to see those who are. I just want to be sure, because it's in the end that I'm going to, calculate the great things you've done already. Yes, Priscilla. What's your question? So let's explain a little bit about this density plot. First thing, for quantity demanded to be normal, the bell-shaped curve must show. The bell-shaped curve has only one peak, one mode. How many modes does this density have? Who can tell me? How many modes does this density, Richard?
Doc, it has two modes.
It has two modes. And the fact that it's got two modes clearly is an indication that it's not normally distributed. The modes are centered in 150 and 200. In other words, there is a high probability mass of concentration of the data at 150 and 200. That is not normal. But using a graph alone to determine the normality is not enough. By the way, there's another graph you can use. After running the Tiger Start package, okay, you can use another thing called density plot again to show the density, to determine that whether the data is normally distributed. And that is another one that I've just done here. All of these are ways you can determine whether the variable is normally distributed. Now, after you've done that, there is something more we need to look at, okay, other than just describing that this data is normal or is not normal. And to do that, you need to test whether the variable, which in this case is quantity demanded, is normal. I didn't say draw. You have already drawn. But this time, you test whether it is normal. No longer drawing, but testing. How do you test? Well, you should test by writing the command. There's a command in your work, and this command is known as Shapiro.test. If you don't have it, just follow me and just write it. I'm writing it here for all of you to see, making it bigger here. It's called Shapiro, S-H-A, and you see, once you type and you have internet, the Shapiro, the test will show. Shapiro.test. So just click on that. And then inside the brackets, you just write the name of the variable you are checking. And the name is $Q. That's all. So the test I'm about to run is this test. Run it. Run it and tell me your p-value. When you have run it, raise your hand and tell me your p-value. Elam, what is your p-value?
Sorry, let me. Yeah, so that's 0.00387.
0.00387. That's good. Okay, I'm giving you 2 marks for that. Now, Shapiro.test. I didn't run mine because I didn't want any of you to copy me. Okay, so now I'm going to run mine, and it is true. The p-value is the one that is down there, 0.00387. Please note this. What does this p-value tell you? Whenever the p-value for normality is 5% or less, it means that variable is not normally distributed. When the p-value of normality test is 5% or below, it means the variable is not normally distributed. Yes, Sarah. So who can tell me whether our variable that we have, quantity demanded, whether statistically speaking, this time, whether it's normally distributed or it's not normally distributed? Who can tell us? Joel Donko.
So it's not normally distributed.
Why?
Because you just made mention, if the p-value is less than 5%, then it's not normally distributed. If it's above 5%, and then it's normally distributed.
Very good. Excellent. I will give you different variables, and I will ask you to determine whether they are normally distributed. And I will specifically ask you to use 2 graphs and a test. So the graphs you can use histogram, you can use kernel density plots, you can even use violin plots, you can use scatter plots to determine whether there is normality or there is no normality. Okay. So take note and know how to work on this. Now, let's go to the next thing. The next thing is to generate the correlation matrix that you did in Excel, also here in R. So let me go back here. Okay. You're going to generate the correlation matrix. And to do that, go to your slide. You see a name, okay, called correlations. Okay. And because we are using the not coded data. Okay. We are using the data that is not coded. So you see in your graph that you have core gene, and those core gene, you cannot use them because they all use the coded data. Okay. So you should go to the one that does not use the core gene. You should use the one that has the core gene minus which. Those are the ones we are going to be dealing with. Core gene minus which, because if you use the other ones, it will not work. But what does this cogent minus which means? By the way, the cogent minus which, the first one I have here is the one I've highlighted. The minus which removes the categorical variables before you are able to run your correlation. Please note, there's a difference between correlation matrix and scatter plot matrix. The correlation matrix is a table of rows and columns that has the numbers in them. That's a correlation matrix. A table of rows and columns that have numbers in them. The scatter plot matrix is a table of rows and columns that has graph or plots in them. You're going to do both. Let's do this correlation matrix first. Okay, on your screen, I've generated a correlation matrix. It's only on the numerical variables. So there's no categorical variable here. You can, there's decimals are many, so you can always run them. Then I'm also going to generate the next command, which you have them also. You should do the same, which is the scatter plot matrix. The scatter plot matrix is showing you the graphs on the right. I made the color red. You can change the color and make it blue. Okay. If I make it blue like this, everything here becomes blue. What is blue? Oh, sorry. Okay, is this one. You have to use the one that has the one that has got this information in it. So that's a blue showing. Yes, Sophia.
Yeah, whatever below.
Yeah, no, please. The correlation on mine retained an error. It says that S must be numeric. I don't know if there's any error.
Yes, I told you that you should use the command, the one that has a command with negative which. You didn't run
that's
that
what
one.
I use.
No.
That's what I use.
Well, if you use the one that has the command negative which, you must have the location, occupation, and religion there.
Okay. Okay, I think I have location and origin, religion, sorry. But I don't have the.
Yeah, so that's why you are being punished. Okay. So how can you write some and leave the other? It was very specific.
Okay, sure. Thank you.
All right, now, once you've gotten that, let me ask you some few things about the scatter plot matrix before we move on, because this is very important. And you have like 7 questions on this. So it's important you understand. The scatter plot matrix shows the relationship between every variable and every other variable. For example, the correlation between Q and P is reflected here. So when you move Q downwards and P leftward, where they meet, that is the link between the Q and P. Who can tell me the relationship between this Q and P as we see on the screen? Who can tell me? What is the relationship there? Just looking at the graph. Kwame.
Is it negative?
It is negative. Okay. Who can tell me the relationship between Q and C? Q and C. Q and C. What is the relationship? Q and C. Frederick.
It's positive.
It is positive. What about Q and M? Q and M. Giftinyako.
Positive, Doc.
It's positive. Now let me trick you guys. What do you think is the relationship? And again, think well. Between P and M. Between P and M. What do you think is the relationship between P and M? Between P and M. Yes, who can guess? Because the graph must give you a sense of guessing. Christian.
It appears to be a weak.
Oh, you forget about
negative relationship. A weak negative correlation. Okay. I think it's a negative correlation, please.
It's negative. Okay, it's negative. So sometimes I will ask you the question that using a scatter plot matrix of all the numerical variables, determine the correlation between this and that, this and that, this and that, this and that, this and that. That's what the question will just be. And to be able to answer that question, you should be able to generate your own scatter plot matrix of the data I have given you, and then you'll be able to now answer that question. Fantastic. This scatter plot matrix, it only tells you whether the relationship is positive or negative. It doesn't tell you the actual numerical value. But you need to know the numerical value. What will give you the numerical value? It is the correlation matrix, not the scatter plot matrix. The correlation matrix we derived above, that will give you the numerical value. So for example, between price and M, okay, our dear friend just said it appears to be negative. That appears to be negative. That is a value here. The correlation matrix gives you the exact numerical value. And I like what he says. He says weakly negative. And you can see that it's weakly because it is 51% negative. So it's not strong. It's not above, 51 by much. But there's more to this, ladies and gentlemen. You can even run, and you should learn to run, a correlation matrix plus its p-value. Let's do that in this command. I'm rounding it to 2 decimal places. Okay, so that's why I started the command with a run. Okay, and then I'm still using the variables without the categorical variables. So let's run that command. And at the bottom, you see, it gives you the correlation in 2 decimal places. But let's generate rather the one with correlation as well as the p-value. To do that, you need to run the library package called H miscellaneous, HMISC. Run that package. You all have it. After running the package, there's a command which is known as rcall. Rcall into bracket as dot matrix. And you have it in your slides. So you can appreciate why I said you should type the commands before coming. Because if you are typing the commands now while I'm talking, you will have to type a lot. So let's run the rcall, and that will give you that beautiful correlation at the top. The correlation matrices are given at the top. And then the p-values are given at the down. Please follow me and know how you interpret this. Who can tell me, just looking at the correlation matrix, who can tell me the correlation between Q and M? What's the value? Q and M. Q and M. What is the value of that correlation? Joel.
0.61.
Perfect. Who can give me the correlation coefficient between between price and complement price? Between price and complement price. Emmanuel Kashi.
Minus 7.4.
Minus 0.74. So you can use the correlation matrix to be able to guide you. But let's take the first one. Okay, the first one, which was 0.61. 0.61. My question to you is that correlation coefficient, I know it's not positive, we all see it, but is that significant? Is that significant? And whatever you say, I'm going to ask you, how did you know it was significant? So know that first. Is that significant? Don't guess, because if you guess, you'll be wrong. And I'll ask you, how did you know it's significant? Now, in order to know whether a correlation is significant or not, check its p-value. You see, The p-values are all shown down there. That's the p-value. They are all shown down there for each variable. The same way there's a connection between a variable and a variable in the correlation matrix. The same way there's a connection between a variable and a variable in the p-value section. So for example, the correlation between Q and M is 0.61. If I want to know whether that is significant, I come and check the p-value between Q and M. Who can tell me the p-value between Q and M when you come down here in the highlighted blue section? What is the p-value there between Q and M? You tell me exactly what you see. Pamela.
It's 0 exponent 0, 0. So 0, basically.
Exactly. 0 exponent 0, 0 is 0. Now write this down. Whenever the p-value is 5% or less, it means that the correlation is significant. Whenever the p-value is 5% or less, it means the correlation is significant. So in order to tell whether this particular correlation is significant, you have to use the p-value. And the p-value will tell you that the one you saw above is significant. Now, some of the p-values, they are quite strange. Who can tell me the actual meaning of this p-value? The one I've highlighted. The actual meaning of that p-value, 7e minus 0.4, 7 exponent minus 0.4. What does that p-value actually mean? What does that p-value actually mean? Okay, Christian.
It means 7 exponent negative 0.4 of, in other words, 0. Yeah, 7e meaning 7 exponent 0.4.
Okay, thank you. Ladies and gentlemen, please note that anytime you have a number with an exponent something something after it, if the exponent is negative and it is negative 0.4, it simply means that there are 4 zeros before the 7. Before the 7, that's why it's negative. But if it is exponent plus 0.4, it means that there are 4 zeros after. How do I say? There are 3 zeros after the 7. So when you have exponents like 7e minus 4, 7 exponent 0.4, what it means is that there are 4 zeros before the 7. 4 zeros means that you have 0.307. So it's 0.0007. That's what it means. And then when it is plus, it means that there are 4 zeros, 3 zeros after. Now, please note that when it is plus like this, it means that there are 2 zeros or 1 zero after this 0. But this is already 0, so it simply means that it's all 0. That's what it means. So it means that the 0 before the E has 1 more zeros after it. All right. So you should just know that in this very example, it is just showing the number 0. That's all it means. And the rule is that when it is 0, it means it's less than 5%, and therefore the correlation above is significant. So learn it very well to help you. Now let's go to correlation in the Excel, in the slide. I'm going to ask you some important questions in the slide. So please open your slide. I'm going to show you the way Excel, generates the correlation. The good thing about Excel is that it doesn't give you the correlation, all of it. It gives you only the left bottom part. Okay. So all these parts are empty. All those that are on the right diagonals have a value of 1, 1, 1. And that means that they are perfectly correlated. If I were you, I would have written that down, but I'm not you. Okay. So that is what we mean by perfect correlation. Perfect doesn't mean high. Perfect is simply 100% correlation. High means 0.99999. It's never perfect. Perfect is 1. Anything below 1 is high. Comparing it with another one is high. So 0.7 is high, 0.8 is high, 0.6 is high, depending on what you are comparing. For example, if I'm comparing 0.2 and 0.6, then 0.2 is high. Okay, now I have some 9 questions here. Question number 1. Which 3 pairs of variables are perfectly correlated? When I say a pair means A and B. A and B. And when you write the answer, you now tell me the number that guided you to know that there's a pair. So which 3 pairs of variables are perfectly correlated? Let me take you back to the result. Look at the results. Which 3 pairs are perfectly correlated? Perfectly correlated. Ellen.
So that would be Q and Q, M and M, OT and OT.
And the values?
Oh, sorry, the values are 1 for all 3.
Good. So anytime you mention the correlation coefficient, you also mention the values. Okay, very good. Right. That's it. That's what we mean by perfect. Okay, so perfect is too easy. I will never ask you that in an exam. But I will ask you something like this. By the way, which variable is the dependent variable? We said that from the onset. Which variable is the one being influenced by other variables in this story? Which variable is that? Gifting apple.
Q, Prof.
Good. Please note that the dependent variable is always written first in the correlation matrix.
But please, I had a question.
Yeah, go ahead.
So is the highly same as perfectly? Is that what you said?
No. Highly is never the same as perfectly. Highly is different from perfectly. Highly is something that is close to perfectly, but is not perfectly. Okay. Now, we know what the response variable is. Please, another name for the dependent variable is response variable. So who can tell me this? Which 2 pairs of variables are most strongly correlated with the response variable? Which 2 pairs? Which 2 pairs of variables are most strongly correlated with the response variable? Let me take you back to the table. Which 2 pairs of variables are more? And please mention all the 2 pairs. And I've shown you how to mention the pairs. You mention it, then you tell me the number. Theodora, sorry.
QP negative 0.87.
And what's the next one?
And the next one is OTRQ 0.78.
Very good. The way you numbered them is very important because you did it orderly. The highest one first, followed by the next higher one. And that's how you should all mention them. Okay. That's a very good answer and a good 2 marks for you. Who doesn't understand? Who can tell me 2 pairs of variables that are least correlated with the response variable? Who can tell me? 2 pairs of variables that are rather least correlated with the dependent variable. So fair.
Okay, Doc, so it's the first one is OTQ, which is
There's
0
nothing called
negative.
OTQ. It is rather OT and Q.
Oh, sorry. Okay, OT and Q. which is negative 0.11, and then M and Q, which is 0.61.
Perfect. Excellent. Let's go to the next question. Before we answer the next question, write the meaning of multicollinearity down. Multicollinearity. Write the meaning down. I'm going to define it for you. Multicollinearity exists when two independent variables are so highly correlated that multicollinearity exists when two independent variables are so highly correlated that it becomes difficult to separate the partial effect. It becomes difficult to separate the partial effect of one from the other on the dependent variable. It becomes difficult to separate the partial effect of one from the other on the dependent variable. So one thing you will note about this definition is that multicollinearity has to do with two independent variables that are high. Two independent variables can be high. For example, your salary can be affected by your wage. Sorry, your salary can be affected by your education. Your salary can be affected by your education, but also your salary can be affected by your experience. But what if in your company, your master's degree will be financed by the company only after you've had 5 years of experience? And then your salary will go up. Let me repeat. In your company, the company is willing to finance your master's degree after your 5 years of experience in the company. Then, when you return, your salary will be increased. What does that mean between education and experience? Joel.
So it means positive correlation, because the education, the experience goes with your education. The higher you go with the experience, the more your education, the education goes with the experience. So it's matching according to the experience you have had in the company. So that's why I said it's positive correlation.
Yeah. And it's probably that it is highly positive. Why? It's probably that it's highly positive. Why? You can tell me. It's probable that it's highly positive because you will not get your salary if you have your experience. Even if you have your 5 years experience, you will not get your higher salary unless you have had your degree. Unless you have had your degree. And so your degree you will have requires that you also have the experience. Your degree requires that you have your experience already. And so your experience should motivate your degree, and your degree should motivate. So the question is that your salary, what is really affecting your salary? What is really causing the increase in your salary? Is it your education or your experience? Susan.
Yes, sir. Sir, please, it's your experience.
Christian, what about you?
I think it's both, because you cannot get the benefit as in the salary increment independent of one. So both are moving in tandem to give the results that is the salary increment.
And that is why education and experience in this context will be multicollinear, because they are highly correlated. Now goes my question. My question is this. Which three pairs of variables are mostly multicollinear in the data? In the correlation matrix, which three pairs of variables are mostly multicollinear? Without copying from anything, who can tell us the answer? Which three pairs of variables? Irene. Irene. Yes, Gifty Nyako.
Hello, Prof. Hello.
Yes, but should I let Irene?
0.76.
Irene, I think that there's a problem with your network. Each time I call, it takes you a longer time.
No, it's getting to unmute. It's what takes a long time.
Okay. Give us all the three
So,
pairs.
please, can I speak?
Yes, give us all the three pairs.
-0.7. Negative 0.74.
Don't only mention the numbers, mention the pairs for me.
Oh, okay. So the first one is RM and Q, which is negative 0.76. And then the second one is C and P, which is negative 0.74. And the third one is I can't find it. I'm lost.
Okay. So let someone take over. The first one was wrong.
Do I go? Yeah.
Yes, Gifty, go ahead.
Okay, so I have P and OTR, which is 0.76. Then P and C, which is negative 0.74. And the last one is M and RM, which is negative 0.73.
Yes, correct, Gifty. Now, so these are the values. Who can tell me why we did not include this value, negative 0.87? Who can tell me why we didn't include that? Why didn't we include that value? Sophia.
So the definition says other than the dependent variable.
Good. So that is why we didn't include that. So even though that value is high, it is not an independent variable. The independent variable is everything apart from this dependent variable column. That is what you focus on. Now, who can tell me three pairs of variables that are rather least multicollinear? Who can tell me three pairs of variables that are rather least multicollinear, not mostly multicollinear? Elam.
Okay, so that would be OT and M at 0.03. And then RC and OT at 0.05. And LU and C at 0.14.
Very good. That is all correct. Why didn't we include this number that was rather smaller than the 0.14? 50. Frederick.
Because it was in the dependent variable.
All right, okay. So it was the dependent variable. So now let me ask you the next question. Who can give me 3 pairs of variables that are least correlated? 3 pairs of variables that are least correlated. I did not say 3 pairs of variables that are least multicollinear. I said 3 pairs of variables that are least correlated. Don't give me. Joel.
Yes, the first one is OT and M. Negative 0.03.
Okay.
Then the second one will be RC and OT. 0.05. Then the last one, OT and Q. Negative 0.11. Negative 0.11.
Good. Question. So what is the difference between correlated and multicollinear? What is the difference between collinear and multicollinear? What is the difference between correlated and multicollinear? Gifty.
The multi excludes the dependent variables.
And
the collinear is part of the variables. You can include the dependent variables.
Good. Guys, it's very important you're following these things. Okay. All right. So that's it on the correlation part. Now, let's go to regression. A regression, write this down. Regression, no, write this down. Correlation is to association, but regression is to causality. Correlation is to association. Regression is to causality. So correlation looks at the interrelationship between two variables. It doesn't even tell you that one is causing the other one to happen. No, that's not how it works. For example, do you all know about profitability and CSR, corporate social responsibility? What do you think is the relationship between them? What do you think is the relationship between profitability and corporate social responsibility, Manokash?
So it has a positive relationship because when profits are more, then we engage in more corporate social responsibilities.
Okay, very good. So the more CSR you do, the more profit you are likely to make. But please note that the more profit you make, the more CSR you are likely to also do. So which one is the cause? Joel, which one is the cause? Christian.
I think the CSR, corporate social responsibility, is the cause because that is a tax deductible activity. So when you engage in CSR, your profit will go up because that activity, the cost of that activity will be deducted from your income before your tax is applied. So that will lead to higher level of profit. Then you can do more of the corporate social responsibility subsequently.
But what if somebody also tells you that I'm not able to do more of the CSR anyway because I don't get more profit? So it is when I get more profit that I will do CSR. You get a point? So we can say that they are related, but we cannot establish causality. There may be endogeneity. It's possible that CSR causes profit to go up. It's also possible that profit causes CSR to go up. We just don't know. And one thing about correlation is that you cannot establish causality. You can't establish causality. But in regression, you draw on causality, and that's a good thing I want to say. So what is regression? Regression is a technique that is used to establish the causal relationship. In a regression, there is a dependent variable, which is also called outcome explained response, regressand. There is an independent variable, which is also called predictor, explanatory, regressor. All of these terms, I'm just mentioning them so that you can write them. So in the correlation, in a regression, there are two kinds of the main regression. In fact, there are four actually. There is one where you have the dependent variable to be 1. And then you have the independent variable also to be 1. What kind of regression is that? A regression where the dependent variable is 1, the independent variable is also 1. Christian, what kind of regression is that?
Perfect.
Nope. In a regression where the dependent variable is 1, the independent variable is also 1. What kind of regression is that? Guys, wake up. Wake up. Fine.
Is it linear?
No. It's called a simple regression. And it's on your screen, by the way. A simple regression. A simple regression is one where the dependent variable is 1, the independent variable is also 1. Now, when the dependent variable is still 1, but the independent variables are many, what kind of regression is that? The dependent variable is 1, but the independent variable are many. What kind of regression is that? Lucian?
Multiple.
Good. Now, these multiple independent variables, they are numeric. They are all numerical. When some are numerical and some are categorical, what kind of regression is that? The independent variables that are in a multiple regression, they are numerical. That's why it's multiple regression. But when some are numerical and some are categorical, what kind of regression is that? Hello.
That's a dummy variable regression.
It is a dummy variable regression. Now, the regression I have on top of your screen here, what? Oh, no. The one I have on top of your screen here, what kind of regression is that? These 3 regressions you've mentioned, what kind of regression could that be? Kwashi?
Simple linear regression.
Good. What made you say that?
So y is dependent on x.
Good. That's it. What is the name of the y? You can tell me. What is the name of the y? What is the name of the y? Question.
Y is the dependent variable.
What is the name of the x? The x. Joel.
Should I answer that one?
Independent variable.
And what is the name of the beta knot? The beta knot. It's actually beta knot. What's the name of the beta knot? Irene. Irene's hand is gone down because she didn't think I was going to ask her about the beta knot. She thought I was going to ask her about the x. Is he live? Yes, Emmanuel.
That's the y-intercept.
Sorry?
That's the y-intercept. Well,
y-intercept, that's a mathematical thing. The beta knot, another name for the beta knot is what? The intercept, that's what you meant. But there's another name. What's another name for the beta knot? Joel?
The gradient.
No, it's not a gradient.
say predictor.
It's not predictor.
Is it not predictor?
What is another name for this intercept? This one, if you know, you know. And I'll ask you all this. So it's important you are following up. It's important you are not dozing off one bit. Okay? And that is the constant. In Excel, if you did your Excel,
No, I was going to say that.
you see that you were going, it's always like that. You're going to say, if you did your Excel, you would have noticed that Excel called it constant. What is economic interpretation of the constant? Go and find out. Go and please find out the economic interpretation of the constant or the intercept. Okay. Now, what does the beta 1 mean? Okay, now let me go to a practical one. What does the beta 1 mean? Okay, the betas. The betas. Whether it's beta 1, beta 2, what do they mean? There's another name for the betas, by the way. What is another name for the betas? Aaron?
Parameters.
Parameters, I love that. Okay. Once they have been estimated to have numbers, what is the name for them? Write these things down. Write these things down, Richard Labby.
Coefficients.
They are called coefficients once they have been estimated. So they are estimators, but they will later become estimates. They are estimators, but they will later become estimates. That leaves us with one last thing in the regression model. What is that? That leaves us with one last thing in the regression model. What is that? There are some of you, you have been sitting here since 1912. You will never talk because you have decided that even if you know, you will never, ever open your mouth and talk. So you continue relying in your cubicle and enjoy the aroma of the food. Enjoy. Enjoy. Okay. All right. Lucian.
So it's the U, that's the residual.
There are 7 names for this residual. And if you check past question, I will always ask you, who can give me one of the names of the residual? Who can give me one of the names of the residual? Nadia.
Unexplained error.
What?
Unexplained error.
Unexplained error, good. Another name for this U-term, this unexplained error. Pamela.
Random noise.
Random noise. Another name for this random noise. Jordanko.
Disturbance.
Disturbance thing. Very good. Another name for this disturbance thing. Aaron.
Unobserved heterogeneity.
Unobserved heterogeneity. Okay. Another name for the unobserved heterogeneity. Aaron. Elon.
Idiosyncratic error.
Idiosyncratic error. Another name for the idiosyncratic error. Nadia.
White noise.
White noise. Another name for the white noise. Hello.
That would be stochastic noise.
Stochastic noise. Another name for the stochastic noise. The residual. The residual. Ladies and gentlemen, ensure you know at least 7 names of the error term. What does the error term do? The error term captures all other factors that are hidden, unknown, but can also influence Y, the dependent variable behind the scenes. What is the X1 and X2 doing? They are trying to explain or influence the Y. The Y can just be something. I'll give you examples very soon. And what the X and the X1 and X2 are doing is that they are influencing the way Y behaves. Y can be marriage, the marriage relationship. And in this marriage relationship, there are several factors that can affect Y, the marriage relationship. What is the main factor that can determine the marriage relationship? What is the main factor? What is the main factor that can disturb the marriage relationship? Well, let's mention the main factor that can affect the marriage relationship. Sophia.
Money.
Money. What is another factor that can affect the marriage relationship? So money is X1 here. What is another factor? Elo.
Children.
Children. So children and money. So children and money can affect the marriage relationship. Okay. Money is the X1. Children is the X2. What then is the beta 1, which is attached to the X1? What then is the beta 1, which is attached to the money? What is that beta 1? The betas tell you by how much each independent variable affects the dependent variable. Write it down. The betas, they tell you by how much each independent variable affects the dependent variable. So by how much do you think the money will influence the marriage or the relationship? By how much do you think that children will influence the marriage relationship? So the betas are numerical values that will tell you the extent to which that particular independent variable can affect the dependent variable. But what then does the error term capture, the UI? What does it capture? The error term captures other factors that can affect this marriage relationship but have not been captured yet in the model. The only ones that have been captured are money and children. But there are other factors, other seemingly relevant factors that can affect the marriage relationship but have not yet been captured in the model. Who can tell me one of them? One of those factors. By the way, I'm the only one who will determine what you say is relevant. So if what you're about to say is going to be relevant, I'll say it. Give me one factor that can affect the relationship but hasn't been captured here. Vivian.
Sex.
Sex. Very good. What other factor? Vivian has not spoken. No. Vivian has never spoken today. And that was her first answer. Yes, next person, Ronnie.
It's communication.
Communication is difficult to actually measure because it's kind of a broad thing. There's so many ways you can communicate in the marriage. So that makes it too complex to measure. What other factor, Abigail?
Doc, love.
Love, again, is difficult to measure. You see, I don't want these love, integrity, loyalty, those things, please put them aside. Let's deal with the reality because abstract things are difficult to measure. Joel.
Sir, in-laws.
In-laws, very good. In-laws can influence the marriage significantly. Very good. Gift Nyako.
So sickness.
Yes, sickness can influence the marriage well. Jemima.
Education.
Education can influence the marriage. Some of you, your marriages are being influenced positively or negatively because of what you are doing right now. Yes. What else? Theodora.
Disability.
Hey, Theodora. 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 Okay, let's go to Vivian.
Religion.
Religion, very good. Stephen.
About to say
Religion. Adeline. Adelina.
Stepchildren.
Okay, somebody has mentioned those children already. Okay. Irene.
Side chicks.
Side chicks. Very good. Irene, you are sitting on some water. Very good. That is so true. Eh? Okay, Karen.
Six.
Karen, somebody has mentioned it. I don't know why you like it a lot, but somebody has mentioned that already. All right, so these are some factors that can affect. So now you should know that the error term, which is a UI, are unobserved. They are unobserved. They are hiding behind the scenes, disturbing the relationship. Okay? So for example, if you are even talking about rainfall and yield, rainfall is a factor you don't control. Yeah, usually some of these unobserved factors, you can't really control them. You can't control them. Let's take a typical example and then look at a typical example, a practical example of a regression model. Remember, the model has no numbers. Wage is affected by education. There's no doubt about it. Wage is also affected by experience. There's no doubt about that. By position, by ability. For 2 marks, tell me other factors which are inside the U term that can affect the wage but haven't been captured here. And please note, we want relevant factors. So don't mention things like hours of work or productivity or performance. No, relevant factors. Which other factor can affect wage but hasn't been captured here? Relevant, Joel.
Overtime.
Overtime, 2 marks. What else? Vivian.
So he's mentioning what I wanted to see.
Okay. Gifty.
Promotion.
No.
Fit.
Promotion is not.
Okay.
It's been captured already. Karen. Irene.
Geographic location.
Location. Very good. The people
Location.
in London are paid more than the people outside London. Frida.
Risk factors.
When you say risk factor, you've not really spoken. Give me details of what you mean by that.
So the type of an organization
Very good. Now
that you work in.
organizational type, okay, the industry type can affect. I'll buy that. Jacob.
The skills.
The skills is into your experience. Okay. Christian Morte.
I think that the units, for example, in the banks, those in treasury tend to earn higher than other departments.
But there are people who are not in treasury, they also tend to earn higher
than others. Well,
yeah. So it all goes to the type of organization, the type of industry, the type of unit, the type, everything related to the type. Cheryl.
Okay.
Trade union, they are bargaining.
Trade union, very good. These are people who are watching my videos. Very good. Frederick.
Performance.
I said nobody should mention performance, and you're saying performance. Finally, Kwame.
Gender.
Gender doesn't come in. Take it from me. You don't use that to determine your salary. So you said, during your interview, you say you are a woman. So because you said you're a woman, then they increase your salary. All right. Let's look at another situation. Your blood pressure is affected by your age, by your weight, okay, by your stress and pulse. Of course, there are other factors that can bring about your blood pressure, but haven't been captured here. Those factors are inside the error term. For 2 marks, just tell me those other factors that can affect blood pressure. And please, nobody should mention broken heart. Nobody should mention broken heart, anxiety, or depression. Okay, so let's start. Karen. Karen Amankwa. That's the second time she's raised her hand and she never responded. All right, so let's go to the next person. Frida.
Sir, medication.
Medication. Very good. And please, nobody should mention any other thing that you put into your mouth. Okay. So I'll put things like diet. I'll put diet, I'll put smoking, I'll put alcohol, medication all together as one thing. Okay, good. Medication. Let's go to Susan. Oh, she's gone.
Yeah, I was going to say smoking.
All right, so you're out. Let's go to Jemima. Adichumwa.
Sex.
No. Okay, let's continue. Nadia.
Exercise.
Exercise. Very good. That is a perfect answer. Very good. Next one. Who has another example? Lucian.
Genetics.
Genetics. Perfect answer. Hereditary. Very good. Next one. Theodora.
Pregnancy.
Pregnancy. Good answer. Very good. Abigail Brown.
Sleeping habits.
Sleeping habits. Hi. Sleeping habits. Some people say I shouldn't buy it. Okay.
Oh, sorry.
She's coming to defend it. I'll buy it. I'll buy it. Harriet Abbey. You said your own. Take care of. Next, Frederick Marcelo.
Lifestyle.
Lifestyle is too broad. Difficult to even measure and count. Everything here we are talking about is lifestyle. Vivian Seno.
Say your diet.
Diet. I mentioned that medication, all of those things that enter your mouth is the same thing. So that's it. Now, who has another relevant thing? Relevant. Christian Motte.
Sedentary work.
Nope. Gift Nyako.
Activity.
Jaroff.
Doug, Doug, I was going to say type of occupation.
Don't even use any of the factors in my listen. No, the type of occupation will not be leading to your blood pressure. Richard Labby.
Medical history.
Medical history. I'll buy that. The other diseases, okay, other diseases can also lead to your blood pressure. Okay, that's it. It's enough. So those are what we mean by unobserved factors. Let's go to the last one. The quantity demanded. Listen before you repeat. Quantity demanded of a product is affected by the price of the product. The price of the product. The complement price of the product. Sorry, the income of the product. The income of the people, that is whether the product is a normal good or an inferior good, the income type. The advertisement, promotion, advertisement, all of that go into advertisement. Okay. The advertisement, that can also lead to that change. And then, whether the good is a substitute or complement. Whether the good is a substitute or a complement, that can also lead to quantity demanded being affected. There are other factors, of course, that can also bring about changes in demand. And they are all contained in the error term. You can give me one relevant factor that is contained in the one factor that is contained inside this. Relevant. Nobody should mention taste and preferences. Nobody. So who can give me the first relevant factor? When I say taste and preferences, 4 hands have gone. Sharon Metal.
Elasticity.
No, there's nothing on that. Next person, Emmanuel Kwashi.
So weather for
weather, very good. Seasonality, you don't need to explain. Weather, seasonality, very good for 2. Eunice Kwashi.
Population size.
What?
The population size.
Population, very good, population. That is correct for 2. Yes, what else? Frida.
It's a price expectation.
Very good, expected price, very good. Irene Yamiche.
Location.
Location, very good. Nobody should mention occupation and religion. Richard Larby.
Government policy.
Very good, government policies, taxes and subsidies, excellent. Sophia.
Demography.
Demography is too broad, you can't capture that. Next. Lucian.
Information.
Information, out. Next. Abigail.
Lifestyle.
Lifestyle, Ampa. Michael Edu. Lower your hands, lower your hands.
So inflation.
Inflation, somebody has mentioned expected prices. Nobody should mention any macroeconomic factor because that will affect everybody anyway. Lillian.
Future prices.
Somebody has mentioned that already. You are not listening. All right, that's all. So, ladies and gentlemen, you should know these unobserved factors. In the assignment I've given you, I've asked you to mention some unobserved factors. I will also ask you to do the same thing in your exams. So understand these things thoroughly. Understand that. I want you to look at the first bullet and the last bullet. I have a question for you there. For 10 seconds, look at the first bullet here. The first bullet is known as specified regression model. Look at the last bullet. The last bullet is called estimated regression equation. Estimated regression equation. Who can tell me 2 differences between the specified model and the estimated regression equation? 2 differences. 2, not 1. Between the specified and the estimated. Just looking at them. 15 years.
I hear you. Plus the UI and the wage I.
You have not spoken. Clearly, simply tell me the differences. This is not a guesswork. Ronnie, Baden.
The estimated has a constant and estimated coefficient, whilst the specified doesn't.
No. No. And besides, I said somebody should tell me 2 differences. So let's go to Sophia.
Okay, Doc, so the first one is that the specified has a residual value.
Very
but
good.
The estimated doesn't have. And then the second one too is the okay, so the estimated have
the error term.
No, they have a coefficient. Why the specified doesn't have?
Very good, excellent. Okay. So I will ask you this in an exam. So it's very important you understood what she said because she's giving all the correct answers. Hit the right nails. So you should know the difference between the specified regression model and the estimated regression equation. All right. There are properties of regression. The techniques for doing regression, this technique is known as OLS. OLS stands for ordinary least squares. Before you can do any regression, and when I say do a regression, what I mean is that before you can estimate the regression model and move from the model to the equation, before you can move from the model, which is a beta, to the equation, which is a numbers, certain things must be assumed. Yeah, those of you whose hands are up, what question do you have?
Yes, sir.
Go
So I
ahead.
have a question. Yeah, the question is, I found myself wondering with the answers Sister Sophia gave. So if you can explain it a bit for me.
Okay, Sophia, explain it.
Okay. Joel, when you look at the estimated one, okay, so you just look at the way the equation is written. The estimated one ends with 0.05 ability, but there's no residual. Yes. Okay. And then when you look at the estimated one, that's the last one as well, you see that, okay, so the equation starts with 150 plus 0.85 education. Look at the specified. It also starts with beta 0 plus beta 1 education. The beta 1 in the specified one at the top, it doesn't have, you have coefficients when the beta value has been estimated or has been determined. So in the estimated, you see that there's a determined value. That's what I can say. They all have a determined value. It's not a beta. The beta has been determined. That's what I can say.
Is it better?
So let's go on.
All right, okay. So for regression, Eunice, your hand is up. Eunice, I don't know why your hand keeps coming up. Please check your Irene. Your hand keeps coming up as well.
I just wanted to say that the betas have been replaced with numerical values with the second explanation so that Joel can understand.
All right, okay.
If I'm okay.
So lower your hands, okay, because your hand went up and down, okay, and so assumptions, I want you guys to go and learn this assumption on your own. It's very important. I will bring it in the exam, so I want to bring it. There are 7 assumptions of the regression. 7. Learn them and understand them. The detailed explanation is in the videos. I don't need to send you the video. When you go to the channel, you'll see in the channel, there's a video that explains each one of these assumptions into details, into two. So look at them. I'm going to now go to the regression to show you how to estimate the regression. I want to go to the model to show you how to estimate the regression. So please, let's remind ourselves on a few things. Determinants of demand in the alcoholic beverage industry in Ghana, impact of location, occupation, and religion. You have a complete structure. You have generated some descriptive statistics, some graphs, some contingency tables. You've checked distributions. You've done some variable analysis, whether there's a correlation analysis. You've looked at scatter plots and so many things. This is your data set. And we are looking at this data set. I want you to please go back to your R. We are going to go to the R and estimate the first relationship, the simple regression in this data. Look at the top here. The simple regression I'm about to estimate, it is a regression of quantity demanded depending on only price. You guys might remember that there are other factors, but I've just considered the price because this is a simple regression. There is an assumption. The assumptions I say you should go and watch. There is one of these assumptions which is known as that the expected value of the error term must be 0. You just write it down somewhere. The assumption is set to be that it's called normality. The assumption is called normality. And it implies that the expected value of the error term must be 0. Now, the error term is a UI. The word expected value refers to mean, average mean. It means that the mean of the error term must be 0. That was why, ladies and gentlemen, when we estimated the model, you can remember that in the estimated equation, there was no error term. Why were there no error term? There was no error term because its mean value is 0. And so there was no need to bring the error term in the model. Now, if you look at an example of equation I have here, is this an estimated equation or a specified regression model? Who can tell me? The one you have for return on assets, ROA, is it an estimated equation or a specified regression model? Who can tell me? Is it an estimated equation or a specified model? So far.
No, it's estimated.
How do you know?
Okay, so the error, the residual, there's no residual, and also the betas are replaced with coefficients, or there's coefficients in the equation.
So the error is 0 in this context. And so our job is to go and estimate this model in our practical example and check the value of the error term to see whether it's gone to 0. To do that, let's go back to our R. Okay. Go back to the R. Okay. And then remember you've loaded the data already, so we're going to continue from there. So in this R, I want you to scroll down and you will see something called plots. Plots. And by the way, when you're able to do that, let me know. You're going to do a plot. Run your plot. It's called plot, kill, tilde, P, color blue, and blah, 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 blah. Plot. And some of you will have a certain challenge I want you to tell me about. You have a certain challenge and they tell me about it. Yes, Sophia.
Yeah, so I got Jane simple not found.
Good. So you didn't get it even the scatter plot. Is that what you're saying?
I'm actually seeing the scatter plot.
That's what I want you to see.
Yeah, I'm seeing that. Okay.
But I just want you to tell me what you don't see. Then I correct it for you. So what do you see in mine that you don't see in yours? That's mine.
Okay, that's a line. I can't see the line. I only see
the line is called a fitted line. So you can't see the fitted line. Who else? Frederick?
Yes, I can also not see the line.
Very good. Jemima?
Yes, Doc, I can see the fitted line.
Good. Now listen, please, all of you. There is a command you have which is called Gene simple equals to LM. You all have it.
Yes,
just
sir.
Below this. Run that command first, and then go back and go and run the plot. You will see the line. Do you see it now?
Okay, yes, I can see mine.
Who else? Who else can see now? Only one person can see.
I can also see mine now.
Very good. So you should have this. Now, this graph is showing the relationship between what and what. Who can tell me? This graph is showing the relationship between what and what. Sophia?
It's the quantity and the price.
Very good. The LM stands for linear model. The Q is the quantity. Then you have a sign, which is called tilde sign, then the price of gin. And then the summary will summarize the result. So you are regressing the Q on the P. That's what you're doing. You are regressing the Q on the P. Take note. And you have the linear model that is shown. Now, those of you who ran the gene sample, I'm sure you saw some results, didn't you? Did you see some results down there in the console, like what I have on my screen?
Yes.
Good. Look at that result critically. That result that you are seeing is a result of the sample regression. Do you guys see the intercept in the results? Yes, you have the intercept there. What is the value of the intercept? What is the estimate of the intercept? What is the estimate of the intercept? Theodora.
390.376.
Okay, always round it to 2 decimal places. So say it again.
390.38.
Good. And what is the value or the estimate or the coefficient? So you see the words I'm using. The estimate is the same as a coefficient. What is the coefficient of price? Yes, give Tinyako.
Negative 10.69.
That is not correct. Who can tell me the coefficient of price? Frederick.
Negative 14.26.
That is an estimate of price. Okay. So you can see that that negative shows that there's a negative relationship between price and quantity demanded. There's a negative relationship between price and quantity demanded. Now, there are so many things. This is a sample regression. Okay, so in a sample regression, this is it. There's not much to tell except when you're doing with the multiple. So I just want to reserve all my comments till we go to the multiple. Now, but before we wrap up some few things, I want you to look at the fitted model. Because remember, we have our data that had a quantity demanded. And you have that in the Excel. Please go back to the Excel and check the first value of Q. What was it? What's the first value of Q? You can tell us. In your Excel, Jemima.
16.
No.
Sorry, 160.
160. That's the first value of Q. That value, it has to be on the line. If it is on the line, its fitted value will also be the same 160. I want to repeat that. That actual value, its fitted value, its predicted value, that's what it means, will be the same as 160. And if it is the same as 160, it means that that blue actual value of 160 will be seated on the red line. To get the fitted value or the predicted value, you run this command called fitted gene sample. And so that first value you saw as 160, its fitted value is what I have highlighted. What is the difference there? What is the difference between that actual value you had and now its fitted value? Frederick.
I can see 2.16.
2.16 thereabout. Now, that is what is called the residual. So when you go to the next command, which is known as residuals gene sample, it will give you for each one of them. The residual you mentioned, that is this. That's a residual. Do you realize, look at my residual, and you might look at yours too. Do you realize that some of the residuals are negative and some are positive? You see that?
Yes, sir.
Good. Those that are positive are those that are above the red fitted line. The positive residuals are above. Remember, the residuals are errors. The errors. There are positive errors and there are negative errors. So those residuals are those that are above the errors, the positive ones, and the below the errors are below the fitted line are the negative residuals or the negative errors. According to the rule I gave you, the rule of normality, the mean of all these residuals should be what value? The mean of all the residuals should be what value? Sophia?
0.
Now you go to my command, your next command, which is mean of residuals. Mean residuals, gen simple. Run that. I just did mine. And you can see the value down there. What does that value tell you? It tells you that there are 16 zeros before the 4. Whether it's negative or not negative, there are 16 zeros, which is approximately what number? What number is that? Hello.
It's approximately 0.
Good. So in your assignment, if I tell you that determine whether the mean of your error term is 0, you have to go through this process I just went through to determine that and show me your result. I hope you got it. Now let's go to the multiple regression and then we can now interpret things properly. By the way, you can do some beautiful 3D graphs there. So you can fidget with yourself on that and get some 3D graphs there, and then you can now fill it. Okay, I've done it in your slides, but I don't want to have all the time. And my interest is going straight to the multiple regression. So go to your command, go down to your command. You see a command called gen multi. That is my interest for today. Gen multi. Gen multi. Run that command, which is known as gen multi. And when you have run it, raise your hand. All those who are able to run the gen multi, raise your hand. If you have not been following us since we started, you will not be able to run it. Because you must have done some things before you got to where we are. Okay. So when you're able to run your gen multi, you raise your hand for me.
Doc, sorry. I'm having a little issue. I got an error, so I want you to help me to check where the issue is.
Okay.
It says object LU not found.
It's because you are using the command that has the coded. You should use a command that has the LOCOCCREL.
Okay. Okay. All right. Thank you.
Let me see by hands, those of you who have been able to run your command. I'm giving you just a minute to show your hand.
Doc, I also did, but it gave me error.
Yeah,
Object
so
location not found.
yeah, so I'm saying that go and use the right one. Don't use the coded data. Yeah, you guys are just running. That's what I see. Because if you are following me, you will see that I was very specific as the one I'm running. And you can see that I've highlighted it here. Okay. So you will go through yours and look at your command and know that the words match mine before you run them. 30 seconds to finish running. Now, if you have already typed your commands, like I told you to do before coming here, you wouldn't even bother. All you got to do is you run it like I've indicated. All right, so I've taken a note of those 7 people who have done a good job by following me on the trend. And those people, I'm just going to give you some marks. For doing some good job. The 8th person, I didn't take yours, so don't worry.
Oh, well, you know, I was having issues. I found where the error was.
And the issues
so
you are having are fantastically part of the whole problem that you have to solve. So, 3 marks each for those of you who have done that. There's no need for me to check because my photographic memory was able to indicate that you were all correct. Hopefully, hopefully you were all correct. Frederick, were you correct?
Yes, sir.
You were positive. No libi, Abi?
No laba.
Very good. So I've just indicated you guys your names on the page. Again, you're going to be rewarded for your good positioning. You are the ones who have been following me till now. All right. So let's run the results. And this is your result. Ladies and gentlemen, in our exams, I will generate a result similar to this, and I will ask you 11 more questions. And I'm going to go through those 11 more questions, not today. I will go through those 11 more questions when I physically meet you next week. Are you ready? But before we go through that, I'm going to just go through one of these questions with you today before we go through. And please write it down. The question is, which of the independent variables are statistically significant? Please write it down. Which of the independent variables? Somebody has asked me, what is OLS? OLS stands for ordinary least squares. Which of the independent variables are statistically significant? Which of the independent variables are statistically significant? Now, ladies and gentlemen, let me ask you, how do you determine whether an independent variable is? By the way, who can mention all the independent variables you see in your data? These ones I've highlighted. Who can mention all the independent variables just as they are? Just as they are. Who can mention all the independent variables? All of Sophia, for 2.
Okay, I'm trying. So is log urban, that's teaching, occupation teaching, trading, real Christians and real Muslims.
Good. Gifting, your hand was up. Is she correct? Gifting.
Yes, Doc.
Okay. So it means that you're also wrong. Who can tell me all the independent variables in the result? Mention the names of all the independent variables. Okay, so apart from the ones that you mentioned, the other independent variables that you excluded, but you should have included, are the P, C, and then M. P, C, M. They are the other independent variables you should have included. Okay. The independent variables are P, C, M together with the rest. Location, urban, teaching, trading, and all of that. Yes, okay.
Can you explain why they are part of it? I remember Okay, can you explain why they are part of it, please?
Can you explain why they are not part of it?
No, please.
The reason why they are part of it is that you thought I was asking you to name the categorical variables. I was not asking you to name the categorical variables. And so what you did is that you excluded the numerical variables. But the independent variables are made up of both categorical and numerical. The independent variables are made up of both categorical as well as numerical variables. Okay. Now, how do you know whether an independent variable is significant? What they are saying is that the estimate for each one. So if you look at underestimate, each one of the independent, please note that the intercept is not an independent variable. Note that the intercept is not an independent variable. It is everything except the intercept. So to determine whether an independent variable is significant, what you are supposed to note is that you have to check the p-value. And the p-values are the numbers on the far right of your table. Follow me, please. The p-values are the numbers on the far right of your table. Every number on the far right of your table is a p-value. Here is a rule. When the p-value of any independent variable is 5% or less, that independent variable is statistically significant. When the p-value of any independent variable is 5% or less, that independent variable is statistically significant. So I'm going to ask you one by one, which one of these independent variables is statistically significant? And then once we are done with that, we are done for today. Christian Mote.
Occupation trading, which is
hey, hold on. Hold on.
Mm-hmm.
Hey, Papa Christian, I know you have the VIM. Let's start with the first one. Tell me whether it is significant or insignificant. Christian.
It is significant because the p-value is less than 5%.
Are you sure? Because that is not
we
true.
Have 0.0, sorry. Okay.
I didn't say you are wrong.
Sorry. I was looking at the table above. The P for P is 0.053. So in terms of percentages, that is 5.3%. So it's greater than 5%. So it's not significant.
Yes. However, if I had asked you to use 2 decimal places, what will happen?
2 decimal places will be 0.5 on the dot.
So what would that be?
It's on the border. It's on the borderline, but
yes.
It is well. 5% is not less than 5%. So we can say that it is still not significant. The value must be less.
Remember the rule I gave you.
Mm-hmm.
See why your colleagues have raised their hand, because they want to say it. So let me first give it to you.
It must be 5% or less.
let me give it to. Let me give it to Gifty. Gifty, what will you say?
I would say it is significant if you lower it to 2 decimal places, because that gives us 0.05 exactly. So it's exactly 5%.
Exactly. So, and I've told you that you should be rounding them to 2 decimal places to make things better for you. So that will make it significant. Okay. What about C? C, you can tell me, is it significant or insignificant? Frederick. Frederick Marcelo, are you with us? He's lowered his hand. Ronnie.
Please, it's significant.
Why?
Because it's less than 5%.
Why? What's the value?
The value is 0.008.
What is the value in 2 decimals? And follow me, that's what we are dealing with. We are dealing with values in 2 decimals. Okay.
The value in 2 decimals will be 0.01.
So next time you calculate the value in 2 decimals before you use it to answer.
Yes, sir.
Okay. So that is significant. M. What about M? Who can tell me, is it significant or insignificant? Emmanuel Kashi.
It's insignificant.
Why?
Because it's greater than 5%.
What is it is? Tell me the value.
Because the p-value is greater than 5%.
What is it? What is the
Because
p-value?
20%.
The next person shouldn't make me ask what is the p-value.
The p-value is 0.20.
What is it?
0.20.
Okay, let's go to look urban. Is this significant or insignificant? Kwame Ba.
Okay, the p-value of Lokerban is insignificant because it's 0.19, which is greater than 5%.
Okay, please note that it's not the p-value we are saying it is insignificant. It's not a p-value,
okay.
It is a variable.
The variable, okay. So
say it again.
Should I take that again?
Yeah.
Okay, Lokerban, the variable is insignificant because its p-value, which is 0.19, is greater than 5%.
Perfect. Occupation teaching, you can tell us. Christian Mote.
It is the p-value, sorry, the p-variable is 0.004, which is far less than 0.05 or 5%, so it's significant.
What is the p-value?
The p-value for OC teaching is 0.00.
What is the p-value? What is the p-value?
No. We're talking about p-variables, sir.
What is the p-value? These are your colleagues were saying it. I think you are not following. Stephen, Ishan, help him.
Doc, the p-value is 0.
That's it. Why do you say 0?
To 2 decimal places.
To 2 decimal places. So Christian, we are converting the p-values to 2 decimal places. So you don't need to go all the way to 0.0004.
That's right.
Okay. All right. So that is what makes it. Now, the occupation trading, who can tell me? Occupation trading. Is it significant or insignificant? Ronnie.
Look, this is significant.
Why?
Because the value gives us to 2 decimal places of 0.50.
0 point what?
0.50 to 2 decimal places.
Occupation trading.
Yes,
is that what you are doing?
That's what you are doing.
No, I'm asking, are you interpreting, are you talking about occupation trading?
Yes, please.
Okay, come again. Go and think about it and come again. Let's go to Theodora, sorry.
It is significant because it has 9 zeros before the 1.08.
It has what?
9 zeros before the
What is that?
1.08.
What is that?
So it makes it 0.
What is that? What is that thing you just mentioned it has? What is that it?
The p-value of occupation traded.
And what is the value? In 2 decimal places, what is the value?
It's 0.
So why didn't you say it's 0 at first? Or you want us to know that, you know, we are now explaining the exponent number to us. Okay, let's go to the next person. I want somebody who just follows the principle of what I'm teaching, you know, instead of complicating things. Religion, Christian, what is it? Kiftinyako.
Doc, please add a 0. Because the p-value is
What is 0?
0.00.
What is 0?
The
You
variable
started by
for
saying, Doc, it is 0.
the p-value is 0, sorry.
Yeah, because you are talking about p-value, all you went to is 0. So take your time and tell me. Tell me about the variable first before you tell me about the p-value.
Okay, so the variable RC has a p-value of 0.00. Which makes it significant.
All right. And then the last one, occupation religion. Who can tell me about that? Frederick.
So the p-value of RM is 0 and it's significant.
All right. So guys, you got to learn these things. You got to learn all of them. Okay? It will help you to be, you should be able to tell whether, but what do we even mean by is significant? What do we mean? Okay? When we say a variable is significant, what does it mean? What it means is that its estimate you see, okay, is significant in influencing the dependent variable. That's what I mean by significant. It is significant here means that it doesn't just influence the dependent variable, but it influences it significantly. So if it is, for example, if you look at price, okay, you are saying that when there's, and we'll come to interpretation next week, when you say that price, the coefficient or the estimate is negative 3.15. What it means is that if you increase price by 1 unit, quantity will fall by 3.15 units. Quantity will fall by 3.15 units. Is that significant? Is that fall in quantity significant? To determine that, that's when you go and check its p-value. So the p-value here and the fact that it's significant or not is telling you how matured that independent variable is in influencing the dependent variable. Okay, let's go through the rest of the notes, okay, until we meet next week. Okay, that brings us for now to the end of the entire caboodle. If you have any question at this stage, please, you can now raise your hand and ask any question at all.